Hello, this is the first topic for the lesson of level 3 for fractions and rational numbers. Hello, this is the first part of the lesson for level 3 of unit 2. And the video you're watching goes with this first topic. Make sure you have the focus notes worksheet from your teacher, or if you're watching this from home, make sure you are taking notes. You can click on the link here to see what the notes should look like. If you're in the classroom and you got a worksheet from the teacher, it should look like this. So the essential question for this topic is, how do we model integer addition and subtraction of rational numbers on the number line? I know that you've seen adding and subtracting fractions before. We want to use the number line to help us understand and visualize the problem so that we can use it to answer real-world problems and help us later on with unlike denominators. So let's review very briefly. How do you model integer addition on the number line? Because that we're very familiar with. We've done that already this year. Remember, when you have a problem like -3 plus 4, the first number is where you're going to start on the number line. So we'll start at -3. We will move this part here. So adding 4, we're going to go 4 in the positive direction, and where we end will be our solution. So in this case, I start at -3. I add 4, so that means I go 4 in the positive direction, and I end at 1. Likewise, if you're subtracting, you still start at the first number, and then the second number tells you the direction to travel and how far, and where you end up will be your answer. So in this case, I start at -3, and if I'm going to take away -9, that means I'm going to go in the opposite of -9 on the number line, which means I'm going to move in the positive direction. If you look at this number line, it's set up to skip by 3s, right? 3, 6, 9, and so on. So I start at -3, and one space is 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I've moved 9, and I end at 6. So -3 take away -9 equals 6. You can apply this exact same concept when it comes to fractions. So consider the concept of a fraction, right? In any form, when you're talking about a fraction, you have the part and the whole. And a whole basically means one whole number, or visually one whole circle, one whole shape, something like that. And then it's broken up into pieces. And it's whatever is in the bottom of the fraction is the number of pieces. So here is a circle. This is broken up into 10 pieces. As a rectangle, this is broken up into 10 pieces. And the part, the amount of pieces, is the numerator, the top number. So 7/10, here you can see I have 7/10. 7 of the 10 pieces are shaded in, and the same here. 7 of the 10 pieces are shaded in. It works exactly the same on a number line. No matter how many pieces this number line is broken up into, from 0 to 1 is still the whole. So if you look at this here, if I'm going to model 7/10 on the number line, the whole part should mean I should have 10 spaces, and spaces are pieces in between 0 and 1. That's me dividing up my whole into 10. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. And then 7/10 would mean that I have 7 of those shaded, or you can move 7 spaces on the number line because my whole is broken up into tenths. So how do we use that to model addition and subtraction of rational numbers on the number line? Well, let's put all of this together. Here's example 1. -3 tenths plus 7/10. The concept of where we start and how we move is exactly the same as for integers. So, we start at the first number, -3/10, and we're going to move by adding 7/10. And wherever we end up, that will be our solution, our answer, the sum. Now, if I look at this number line, from 0 to 1 is my whole, and you can see it's broken up into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's broken up into tenths. Each of these spaces is worth a tenth. That's very important when you're counting, because I'm going to start here at -3/10, and I'm going to add 7/10, which means I'm going to count 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and I end at 4/10. Now, 4/10 is the number. It has the correct value. Remember, in math, if you can simplify a fraction, you should. Just simplify. You look at the numerator and denominator, and you think about if they have a factor in common. And in this case, they have, or a number that divides into both of them is another way to think about it. And 4 divided by 2, and 10 is divisible by 2. So we can simplify. 4 divided by 2 is 2, and 10 divided by 2 is 5. So the final answer, simplified, is 2/5. Let's look at another example. 2/5 plus a -6/5. So again, to model this on the number line, I start at the first number, 2/5, and I'm going to move this second part right here. So I'm going to add -6/5. Now if I'm adding negatives, that means I'm going to go in the negative direction. So I'll start here, I find 2/5 on the number line, and then before I start moving, I need to think about how much each space is worth. Well, again, look at the whole. Here it's fifths, and if we look here from 0 to 1, this segment is broken up into 1, 2, 3, 4, 5 pieces. So it's broken up into fifths. So every time I move a space, it's 1/5, like 1/5, 2/5, 3/5, and so on. So here's how it looks. You start at 2/5 here on the number line, and you take away 6/5. So you move to the left in the negative direction 6/5. So we count 1/5, -2/5, -3/5, -4/5, 5/5, and 6/5. I have moved 6/5, and I end at -4/5. That's a typo. There we go. So you end at -4/5. That is the solution. Let me change this one as well. There we go. Let's look at one more example. Let's look at one where we're subtracting. And again, just like with integer addition, when we do integer subtraction and then compare it to rational number subtraction like this, it's the same method. So I start at the first number, -3/5. So I'm going to start here on the number line, and I'm going to take away -4/5. So that's the amount I'm going to move, taking away -4/5. Remember, taking away a negative means I'm moving in the opposite of -4/5. The opposite of a negative is a positive, so I'm going to start at -3/5 and move to the right. Again, before I start counting, let's look at the spaces. How much is each one worth? From 0 to 1, the whole, it's broken up into 1, 2, 3, 4, 5 spaces. So that means I'm going to count by fifths. So here's what it will look like. I'll start at -3/5, and I will take away -4/5, which means I'm going to go to the right, the positive direction, and I count by fifths. 1/5, 2/5, 3/5, 4/5. And where I end at 1/5 is my solution. For your summary, it needs to answer the essential question. So now that you're done with the notes, make sure you have everything filled in, and then take a look at the essential question again, review it, and then write your summary. There is no sentence requirement, but you need to answer the question in detail. So the essential question is, how do we model addition and subtraction of rational numbers on the number line? If you want something concrete to help you write your summary, you are more than welcome to write a detailed explanation of one example from your notes to answer the essential question. So you could say, first I started out by, and you could explain how you knew where you were going to start on the number line, how you moved and how you knew you were going to move, and how you arrived at your solution. That would be fine.